All right, let's look at problem 18 here. Okay, real quick. It says this illustrates the concepts. Okay, so it's got an amplitude. Okay, this is going back and forth. If it had a spray paint can on here, you'd be able to see the sine curve, and this is the way it's moving. All right. So when it goes through one complete round like this, and I'm going to use this concept for when I solve problems 22 and 23. The radiance that it has gone through in this amount of time, here's the amplitudes, here's the max amplitudes, the radiance that it's gone through in this amount of time is 2 pi. For those of you who've never had trig before, or those of you who did have trig, you probably forgot all this stuff. That when it goes through this thing, the radian measure going through here is 2 pi. So one period, the period of this thing is equal to 4 seconds. All right? The period is equal to 4 seconds. All right? And then the amplitude is 0.8. The maximum A is 0.8 or negative 0.8. All right? And so if the period is 4 seconds, all right, and we can figure out what omega is by doing this. All right, so by looking at that picture earlier, is this amplified? I hope, yeah. Okay, so by looking at that picture, so here's what we had. Here's the picture. Okay, this tells me everything I need to know. If this is 4.0 seconds, this is x is equal to 0.80 meters. X is equal to negative 0.80 meters. Now you might be going, well, that's on the right. Yeah, this is your x. This is your x-axis. This is your time axis. All right? This is not your x-axis. This is time moving along here. And so here's a quarter, 1.0 seconds, 2 seconds, 3 seconds. Okay? So omega is equal to 2 pi over t. All right? The period, t, is equal to 4 seconds. Because that's when it went through an entire cycle. The frequency is equal to 1 over the period. Is equal to 0.25 seconds to the negative 1, or 0.25 hertz. The max velocity is equal to a times omega. These guys are equal to a. Okay? This is much better. That's a max. V max. And a max is equal to a times omega squared. All right? Okay? So this means, now, the other thing I wanted to show you, I want to draw this again, just so you can see it. Okay, there's the displacement. Here's x, here's the displacement. Now, where once again, this is the time. Okay, now I'm going to do velocity on this thing. So the velocity would equal this. The maximum velocity would be up here. And when this is at a maximum, this is at 0. Okay? And then it comes down here. And when this is at 0, this is at a maximum down here, going back in the other direction. And this is at 0 here. And then again, this is at a maximum, so this would be at 0. And then when this is at 0, this is back up at a maximum again. All right? I use that for the other problem too. So that should help you with all the other things, I think, on that problem. Let me pull this back. This is page 2 of the notes. Yeah, we got everything we need. What do they want? The amplitude. That's easy. Oh, it's 0.08. Sorry. I said 0.8, but it's 0.08. The angular frequency. Omega equals 2 pi over t. The spring constant k. Oh, did we get what k was? That might be a little bit tricky. The speed of the object at t equals 1 second. Well, that'd be 0, probably. Yep, because we graphed that. Because when t equals 1 second, that's when this is at a maximum. When this is at a maximum, the velocity is 0. Then it starts going. The magnitude of the object's acceleration at t equals 1 second. Oh, well, that's a maximum acceleration. So that's alpha omega t. All right? Good stuff. How do you find the spring constant? Aha! Well, come on back. I'll show you. Spring constant. Don't forget that omega also equals square root of k over m. Did they give you the mass? Sure did. So you can find the spring constant of k. I love these two problems because they show you exactly how to do everything out here.